Okay, anyone get this first one?
Yeah, that's great.
You got it?
I got
Okay,
it.
there's two different ways. There's a long way and there's a short way to do this one, to prove this one. All right?
So I did first was
Why would you do a long way?
I'd probably do the long way, not really.
Look, to divide fractions, you have to multiply. So the first step was to flip oh.
Yeah, be careful. All right, we're talking about dividing exponents here.
I wrote it down.
Dividing exponents. Yeah, what's up?
I did the -3 minus 2 and the 2. Or, I mean, you write it out. Then, like.
So this one right here,
-3.
Avery is saying you do -3 minus 2. So it's going to be 3, -3 minus 2? Minus -2.
That always
Okay. What's that going to equal?
-5. Or, no, -1.
-3 plus, yeah. Okay.
And the other one.
Okay, that's this one. Okay. This is this. All right. What about this one?
Also 3 to the negative in no.
Okay. What's this one gonna be?
3 to -1.
2 minus 3, right?
-1.
Would be 3 to the -1. Okay.
So it is true.
It is true. All right. I want to show you guys the long way though. Does anyone know how to start the long way? Can anyone tell me how to start the long way? Chris Piet?
I have no clue what.
Okay, do you remember what negative exponents mean? I know you missed yesterday. We reviewed all this. We're going to finish reviewing today.
Do I have a quiz on Friday?
We don't have school on Friday.
Oh yeah, I forgot.
So you have a quiz on tomorrow?
Maybe.
No.
Maybe.
Please say no.
I hope so.
Okay, this left side is this. Right? Right? Jamara, do you see how it became this? Isaac, you see how it became this? This left side?
Yes.
You just combine it. Wait, how do you get the 1 though?
Okay, this is what we went over yesterday.
Yeah.
What does this mean right here?
It's gonna be 3 times -3 times -3 -3.
Okay? Why did we do all that yesterday? This means this.
Oh yeah, I remember that now.
Remember the table we made? I did yesterday. What's anything to the -1? It's 1 over that thing.
Mm-hmm.
That's what we were doing yesterday. Remember? Hopefully you remember.
Yes.
Okay.
Whoa.
So here's the top, here's the bottom. All right.
Okay.
And then you have to process this thing to end up with this. Okay, Maxwell, process this for me.
Process that.
Yeah, what does that mean? Simplify this. What is this? It's a fraction divided by a fraction.
Yeah. Like divide it or.
Eli Everett, you with me here? Let me write it in a way that might be easier for you guys to visualize.
I got it.
Oh, you flipped it.
You flip them.
Okay, how do you divide fractions? How many times have we divided a fraction by another fraction? Reciprocate and multiply, right? Do I need to show that step or can I skip it?
You just skip it.
Reciprocate, multiply. All right, you're gonna end up getting this on top and this on bottom. And that is the same as that.
I did that, but I just did a complete shortcut of.
Okay, the shortcut way is great. Okay, Avery's way of just subtracting the exponents is fine. All right?
It was different though.
But it's important that you guys understand where this shortcut comes from, and it's from the meaning of these symbols. Okay, next one. Maxwell.
Okay, so you should start by using the distributive property, I believe.
Correct.
Distribute.
All right, and this is radicals. This is stuff we haven't done for about A month now.
And then 3 times 3 is 9, and 3 times 12 is 36.
3 times 3? Is this 3?
Root 3 times root 3 is root 9. And wait, what? Did I do this wrong? I think I did.
You have to solve.
You're right. Your root 3 times root 3 is root 9.
Yeah, but
Well,
can
then
you simplify
you
that
get
on the end? Can you solve?
Okay.
That's what I did on the end. Then root 3 times root
You
12.
guys remember radicals?
Should you solve the radicals first before?
No.
Okay, that's a, Maxwell's right. And then the next one is what? It's root 3 times 12.
I just,
Remember radicals, when you multiply them, you can put them under one hat?
Can I get some water, please?
Yes, you can.
I'm really thirsty.
Actually, stay here for this problem, since you started it. Root 9 plus, what's this one? 3 times 12?
36.
36
Okay, is equal to, what did I say,
root
9?
9.
And then
And then
And then
Root nine.
30
3 plus
and
6
6.
is 9.
This is 3,
yeah.
this is 6.
Equals 9.
So was it true?
Yes.
Okay, really quick. This is somewhat a trick question-ish. Okay? Because the square root of 9 and the square root of 36, alright? What's the square root of 36? Somebody? Yeah. Just 6? So 6 times itself
6 times 6 is
is 36, right? Is there any other number that you can multiply by itself to get 36?
No.
No?
Yeah.
I'm telling you there is. There's another one out there.
Oh,
Can anyone think of it?
isn't it? No, it's not 9 times 3. It's
No? No.
Same number, right?
Same number times itself.
5.5. Is it
No.
a half like number?
No. You guys are all analyzing it too much.
it's 6 times 4, right? No, it's
It
not.
has to be itself.
It's the same number.
It has to be itself.
Cheat day times cheat day. So you're gonna be right.
Oh.
Tomorrow, what did you say?
Yeah.
Oh yeah,
Okay.
because it becomes positive.
Negative times a negative is a positive, right?
True.
Therefore, Iris, alright, the square root of any number is actually positive 3. Sorry, the square root of 9 is actually positive 3 and negative 3. Alright? Okay? Maxwell?
Yeah.
Square root of any number, positive or negative.
Yeah.
Okay?
Oh.
Negative 6 times negative 6 is 36.
There's no accident. I messed it up. I need to get the camera angle right. I love how like Avery's hand is just in every shot.
Alright, let's pick up where we left off yesterday.
Yay.
Really stoked. Alright, try these out. We're combining properties of exponents.
Combining mom and dad.
I think you're gonna do slow mo video with this level class.
Every day.
Every single one. You should do the manicure.
They did it at Northwest.
All I know that
That
is
was so stupid.
What's that?
like a manicure. Just
He
like
goes cinematographer.
And then the first one wants to run.
Put a mannequin up here? What are you saying?
Oh, the mannequin shop.
Hold up, man.
There's too many challenges.
All just like stand still.
I don't even know.
Yeah, you should do
I would
that.
love that. How about a mannequin challenge where
Yeah,
no,
we should do
no one
find the
talks
air
at all?
What?
Everyone gets silent. You can move.
We would be
Instead of
great.
instead of not moving, no talking. So you can move and write math, but no talking unless.
That's
So
not
they're like
good.
the can. They're like the can. You can, you don't have to.
That's for the go home.
Yeah, it's fun. Let's try it.
Like the quick school challenge.
Okay, here you go. Here you go. Try these two out. Okay, don't be scared by a lot of numbers, alright? I'm trying to scare you guys. That's what I'm trying to do. Okay?
Feel lightly.
This is some pretty scary stuff.
Found it 1/4.
It is, yeah.
Oh, do we have to do like the 1/2 to the third power or the cubed or anything? We have to do that.
1 over. Okay, this one.
Like the bottom half of it. Would it also be like 1/2?
Is that a negative exponent?
Oh, that's
Yeah,
the
great
negative.
concert.
All right, what's this one? What's the top gonna be here? Crispiette, since you missed yesterday.
Oh, it's gonna be 2-6.
2, 6. What about the bottom? It's still 2, 3.
Here is you evaluate that to equal 2.
No, you gotta like.
Over 2, 1. 2, you can like evaluate exponents.
How do you evaluate this?
I mean, simplify.
How do you simplify this?
Okay, so 2 and 2,
J.
and then 2 and. All right.
JJ's just going rogue.
JJ's just going wrong.
What?
That is not what I got.
Okay, no. I mean,
It's how we did it last time. It's exactly the same. It's 2 to the third.
6 minus 3, right?
You
Yeah.
bumped it
You
pretty
subtract the
badly.
exponents.
What?
You bumped it pretty badly.
Exactly the same.
You like B? Maxwell? Is that okay?
Wait, I bumped it. We were trying to get the right angle.
Get rid of the 2. How do you
It's
Wait,
the
what?
exact same.
Because you
Doesn't make
cancel.
sense.
Cancel.
Do you want me to show you how to get here?
Yes.
I got it.
Oh,
Yup.
yes.
Alright. So I did.
Alright, hold on. Go ahead.
Okay, I didn't do that one. Just did 2 times 2 times 2 times 2 times 2 times 2.
Okay, this is the theory. You guys gotta understand the theory behind all these shortcuts.
2, and then I did bang, 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 and then 3 2s was 2.
Okay, just kind of open so people can see you. They're all looking at
Oh,
your
yeah.
back.
And then that is equal to 2 cubed because it
Perfect.
those three.
Okay, he dressed up because he knew he was gonna get up today
Yeah,
and
he
do
was
that. All right. Did everyone see what he did?
Yeah.
Tomorrow,
what
did
I
you
did.
see how we got there?
Oh, I get it.
That's what I did.
Okay. The rule
It's
that
not
I had
right.
you guys write yesterday
Come on, Leonard.
was this. Right here, 6 minus 3 is equal to 3.
That's a lot faster.
Okay? It's a shortcut. But you need to understand why that shortcut exists. Alright? By the way, what's this called? And what's this called?
One of them, oh, that's the base and the index.
This is the base,
The boss and the index.
and this is the index. If you have something like this, Iris, okay? Can you apply that shortcut?
No, because they're 2 different numbers.
2 different whats?
Or bases.
2 different bases, alright? You can't apply this rule to something like this. Got it? Finished? Crispy
It's
yet?
like all in the video.
Tell me what you can't and can't do here.
You can't subtract them because it's different numbers.
You can't subtract the exponents because the bases are different.
Yeah.
Okay. Alright, what about this bottom one here?
Oh, I know what it is.
Avery knows what it is. Avery says it's
Little work, baby.
1 over 4. Did anyone else get that?
Oh.
Eli Everts?
I don't.
Roll it out.
How do you want to?
The top would cancel
Oh,
itself
no,
out.
it's not.
Yeah.
It's a -2.
Yeah, but the other one's positive too, so they would cancel each other out.
True.
He's right.
How? I don't understand.
I don't
the
even get
difference.
that
Then
far.
Why would it? It makes no sense.
Okay,
Just take a deep breath.
It doesn't.
take a deep breath. This is a good place to start, alright? But let's understand this stuff. Okay, let's just deal with this. Okay?
I got it.
This is this. A times A times 1 over A squared.
Oh, I got. Wait. It's just because the numbers are in parentheses. It can equal anything, and then you can just subtract the exponent. So
Is over 1.
the value is nothing.
So
What
you'll
do
end up
you
getting
mean?
A times A over A times A, which will just, they all cancel and you got 1. Alright, the shortcut is you add the exponents. In division, you subtract the exponents. Multiplication, you add the exponents. So if you have something like this, Mac, it's gonna be this. If you have something like this,
Gonna be this.
it's gonna be that. If you have something like this, you're gonna get that. Okay? You see what's going on with the exponents here?
You have to write all that out.
You don't have to write this out. Okay? You don't have to write this out. Okay, right here, what's the base?
4.
4,
Who said that?
2.
Hey man, we're 9
It's
1.
not, the base is not 2.
Eli.
Two,
Say that again? 2x squared. Okay, this is the base. Are the bases the same?
Yeah.
They are. Okay, since the bases are the same, you can just add the exponents. 2 plus negative 2. That's going to give you
0.
0.
this. Sorry, this is a mistake here. You guys don't catch my mistakes. What kind of students are
We
you?
trust you.
Trusting you're a
You're the
teacher.
teacher.
Well, when I get to the lesson where I make mistakes on purpose, you're going to have a tough time.
Yeah.
Oh Lord.
Oh,
I like how that's a lesson.
I'm going to do that. No joke.
He's not yoking us.
What's any base to the 0 power?
1.
Say it with me.
1.
What's any base to the 0 power?
1.
Okay, it's
Okay. Sorry.
1.
All right, and again,
Juan.
if you want a deeper,
Juanita.
if you want a deeper explanation of why that is, let me know. One person has expressed interest. All right. If anyone else wants that, I'll do a little mini lesson on why that is.
Who was that?
I just still don't understand. Like, in every single other thing, if you can't
Every
shift
single
plus and
everything?
negatives and the positive, so why was it okay?
Say that again.
On every single other thing,
Let's see how well
you
it
can't
works.
cancel out negatives and positives.
I don't want you to think of this as canceling.
Well, that's what everyone's making it seem like.
I want you to think of this as if you have
I love this college.
2 squared times 2 cubed, it's actually 2 times 2 times 2 times 2 times 2.
Yeah, I get that.
That's
but-
2 to the 5th.
Fine arts.
but
Okay.
what I'm confused
Eli, I'm
about
opening a fine arts gallery.
is the
Would you like to
You guys, just give me 1 second, you guys.
is the negative. Why is it?
It's the same thing if it's negative. If you have 2 squared times 2 to the negative 3, alright, this is going to be 2 times 2 times 1 over 2 times 2 times 2. Okay? Okay.
So negative's pointless, pretty much.
The negative's not pointless. It makes it this fraction right here.
Fine arts.
Alright? When you multiply this across, you're going to get 2 times 2 on the top and then that on the bottom.
So basically, just think about it almost as a positive, and guys, it'll be the same thing.
It's not pointless. The rule is the same. You just add it. 2 plus negative 3. Alright, these are going to cancel. You're going to end up with 1 over 2. Alright, that's the same as saying this. Okay? If you just add these, you don't have to do any of this work, Mac, and you can just get straight there. You see what I'm saying?
Yeah.
Okay? Multiplying a base with an exponent, you add the exponents. Don't worry about if it's negative or positive.
Coach.
Okay. Here you go.
Are you ready and prepared? Oh.
Yeah, look at my art. Beautiful. I'm putting it in my gallery.
I cut mine.
Okay. This is the last one with exponents, and then we have to move on to radicals.
Cool, dude. Yeah. I cannot sharpen that. That's too
Can
short.
we add the radical term? Or subtract them?
Radicals? We're not doing anything with radicals.
The exponents.
Right, mom, right, mom.
Are the
Yeah,
guys
you
got
can.
them all?
Right, mom. Dude, the bell is until for like 20 minutes.
Like
Stay
30
strong.
minutes.
TJ. I just heard some moms.
Okay, Maxwell Prey, are you okay with this stuff?
In a sec.
Okay, Mac, This is especially important for you, alright? Because that question was asked.
I don't really remember this.
Alright, I'm not going to do the long way here. We're only going to do the shortcut. Okay, what's the numerator going to be, Isaac?
What's the number?
What'd you say?
5 fourths. Or 5.
5.
5.
5. Not 5. You got. I mean, I know what you're trying to say.
5 to the negative
I mean
4.
negative. That's what I'm
What did you just say? 5 to the
negative 4.
negative 4. Okay? You add these. Plus that.
Alright, that far.
And then you subtract the negative 4 and the 3, which is 5, negative 1.
Okay, negative 4 minus negative 3.
Oh, negative 7.
Be quiet.
No, you were right. 5 to the negative 4
Positive 1.
minus negative 3.
It's 5 to the negative 1.
Correct. Okay? What does that mean, by the way? Bennett, what does this mean?
It's just 5. Or it's 1.
This is a symbol that represents something, right?
Symbol.
Oh, it's like 1.
That's what
over.
math is. It's all about
It's
symbols.
a sigil.
Okay, we have all these weird symbols.
Sigil.
This symbol means something. This symbol means something.
Mom means dad.
Is this value negative, you guys?
No.
It's not negative. Remember, Eli Everts. Okay, what does this mean? I know you know this. Yeah, and what's it gonna look like? Okay, it's gonna be this, Bennett.
In fifth.
I did that. I just go to
It's a mountain.
Makes them more fun.
Alright. Back to where we started out the year.
Ollie, can I get some water?
Yeah, good.
My fish.
Ollie, I feel like we're gonna have an exam that covers everything we did over the
We're gonna have an exam that covers everything.
Really?
Yeah, absolutely. But everything's gonna be together.
It's just like me.
Examen.
But
You're reading the video.
I don't even know what to say to that.
I'm putting it in my gallery.
I think I just used the eraser to go like this.
We're gonna do it. You erase it. Cause I'm Eraserhead. Oh,
American
you get
Challenge, are we
that?
doing that?
Alright,
Eli knows his film. You should know that movie.
What?
Eraserhead.
Oh my god.
okay, let's do a real quick breakdown and then I wanna maybe try out a new game.
Eraser Mom. Whoa.
We're doing the mannequin. Okay.
That's pretty cool.
Just read at the top of your lungs, Eli.
I'm doing that. No, it's your. Oh, your hand is your eye.
That hurt. Combine like one.
You have homework today?
No, we're tonight.
You know, you.
No homework this week.
You still have homework you owe me, so.
Oh, it feels that.
So yeah, you do have homework.
It feels that.
You do have homework.
What, Mom?
I swear. Cool out, dude. What'd you say?
What? What do you mean by separating?
Separate under Mom.
Keep it chill. Keep it chill.
Except Mom under dad.
Keep it chill, John.
True, Eli, true.
I am the one.
Okay, he caught me, finally, when you guys caught me.
Nice job,
You know how
Eli.
proud that makes me? I make a mistake and
Did you
someone's
do it on
like, hey,
purpose?
no, I wish I did.
What?
Then I'd be the badass, but
Hey, bad word.
Oh no.
Max on that off. Come on.
Oh, I thought that was recording.
Right under 1 month.
Oh.
We're gonna sue this.
Tell her to come back. She'll look at it. She'll look at it.
Okay? This is all review.
This is hard.
Alright?
Are we just, do we rank?
Still has to be in your notebook.
It's probably like way
Hey, it
back.
still has to be in your notebook. The least you can do is try, alright? Write all this down. Okay?
Favorite class?
Any questions? Anything
Wait, what?
not make
I don't
sense?
understand, like, did we just do this?
Yeah.
It was the first thing
This
we
was the
did.
first thing we did this year.
Come on, good.
Okay?
All real numbers.
Come on.
I tried to
Yes.
say that.
Are we supposed to separate it more, or?
Yesterday and today are review.
I
Chris?
see you there.
Because we're gonna
Yesterday
have an
and today-
examen.
No, we haven't done anything new today. Have you learned anything new today, Chris? We started out with
Kinda.
exponents, stuff we've
But
done.
not
I
really.
do every day.
I
Right?
knew everything.
Maybe not this
I use
class.
that in
But
everyday
it's
life.
important to reinforce your understanding of this stuff for us to do it over.
I use that in everyday life.
But we're not gonna, instead of spending a week and a half on it, we're gonna spend 30 minutes on it.
Damn.
What about like the first 15 minutes or like the last 20 minutes? That we're not spending on it.
Oh
Well,
my.
there's not even 30 minutes in this class, so.
Okay, one example
We have 10 minutes.
for you guys to work on.
I believe we have 10 minutes left in class.
AX.
On
No.
number B,
No, we have. I believe we
why
have
would
15
it,
minutes.
why would it be 30?
What's the inquiry?
What's 18 divided by 6?
I remember this, but I don't remember the answer.
Tell me the inquiry.
And it was
Please, can you rephrase the inquiry?
Final answer.
I don't think I got it correct. Please rephrase the inquiry. Inquiry. JP.
Okay, do this one,
Who's JP?
and
Morgan?
then
Jamara Putney.
we'll do a little experiment.
Who's mine?
I just said that.
Yamara Putney.
What? I was like, what did you just do?
What?
TK, you should finish working on math yesterday because you just left in the middle of class.
When?
During global
History?
systems.
I was with John. We were working on a journal entry. In the hall.
You're supposed to do that before class, I'm pretty sure.
Kind of worry, yeah. Yes, I have my double walk today. I don't.
1 over A.
Gage and I haven't gotten much done.
Okay.
Gage.
You're on the right,
That kid's,
that's the right idea.
that kid's like me.
I don't rely on Gage.
Would it be 1 over
Tell
A
Gage to
squared?
spaz out, or they'll do it. He'll probably be like,
I'll probably just be like, what?
Why?
Why?
$20?
We're doing pretty well. He's working on our mouse, and I'm doing next to ignition, how to fresh out the kitchen.
well, I
Okay,
saw
what's
one of
this?
the
What
older
are we
Trump,
doing here?
it's one of the older Trump SNL impersonations by Alec Baldwin, and I laughed my butt off. It's hilarious. He's like,
Okay, eyes up here. Nick, the radical stage, what's gonna happen? What is this, Bennett? What does this mean right here? This a to the negative 2.
It means A over, or 1 over A.
Brilliant. Boom. Okay, and I just erased this property here. I'll put it back up. I just erased this property.
Should we write that?
I already have, did you?
You should already have this in your notebook.
Yep, I do.
And these are two-sided arrows because you can go both ways. All right. Since you can go both ways, what can we do here? What can we do here? Jamara?
Oh,
What can we do here since
you can make them individual.
you can make them individual? Jamara, what does that mean?
It means split them up into 2 different
Brilliant. Okay? Brilliant. Almost there. Now what?
No.
Now do you
What's the square root of 1?
1.
Okay, and it's going to be positive or negative. All right, for now we can work with just positive square roots. All right, what's the square root of a squared?
A.
A.
1 off.
Okay? And Bennett, What's a different way of expressing this?
A to the negative 1.
Bennett?
Hey.
No?
I said hey.
Bennett. You got it. You got this.
Come on, you got it. Stay strong.
What's a different way of expressing
You
this?
said it earlier, Bennett.
You said it earlier.
Say that again?
A over 1.
No, a over 1 is not equal to 1 over a. Is 2 over 1 equal to 1 over 2? No.
No.
How do you remember?
Hey, let me give it a
Yes.
Were you gonna say that?
No.
Okay.
I was thinking that.
Put me in the game, coach.
Final answer.
What is this?
Ollie wouldn't believe me.
A whiteboard.
Oh, shit, we have.
Okay.
I know, right? Crap.
I don't want to erase you.
Me neither.
Why?
Mac, join that table.
Oh no.